Number 18, taken from the GCSE 9 to 1, November 2018 2H past paper. The straight line L1 passes through the points of coordinates 4, 6 and 12, 2. The straight line L2 passes through the origin and has gradient -3. The lines L1 and L2 intersect at P. Find the coordinates of P. Before we start, let us have this revision. We know that the general equation of a line is equal to y equals ax plus b, where a is the gradient and b is the y-intercept, and any line that passes through the origin has equation y equals ax, because since it passes through the origin, the y-intercept becomes 0. So this is why we don't have the y. So for the general equation of this line, which is L2, you need to know that, or you need to write that y equals ax is its equation. And for L1, you need to know that it's y equals ax plus b, or it can be also y minus y of the point that's passing to it. So if this is a and this is b, you can write y minus. So this is the first equation, this is the second. Y minus y of a equals to the gradient x minus x of a. And here you know that these are the coordinates of a, the point that line L1 passes through, or you can write it as the coordinates of b, because also b lies on L1. So we need, in order to find the point of intersection, we need the equation of L1 and we need the equation of L2. So let us start with equation of L2. Since it has the general equation y equals ax, therefore you write it as y equals the gradient, which is given to us, times x. So we're done. And in order to find the L1, we need to find the gradient. Now, in order to find the gradient, we use the coordinates of the points that that L1 passes through. So the general equation of the gradient is y of b minus y of a over x of b minus x of a, which is in general is the rise over run. And this is what I've done here. So this is the gradient, and then I've replaced the y of a and the x of a in here, and then you use algebra to find the answer. And this is the value, or this is the equation of L1, and this is the equation of L2. Now we need to find the point of intersection. Now you know that when two lines intersect, they have a point in common, and this point, which they called it here b, it has an x of p and a y of p. So when this point p belongs to L1, x of p and y of p satisfy the line L1. And when you replace x of p and y of p in L2, therefore these two coordinates, they satisfy the equation of line L2. Therefore we only have one x for p and one y for p. Therefore we can say that the y of the first equation equals to the y of the second equation. So this is why you have here y equals y. So it's the y of L1 equals to the y of L2, which is literally it's y of p equals y of p, because p has only one y and p is the point of intersection between these two lines. Therefore you replace y of L1 equals to y of L2, and you solve for x. When you solve for x, this is the value for x. Now you take this value for x and you replace it either in L1, so you replace either in L1 or in L2, the one that has the easiest equation to calculate. So again, you replace either in L1 or in L2. Now L2 is easier, so this is why we replaced in L2, and then the y of p would be 48 over 5, and here it's the x of p. Therefore p has the coordinates. This is the x of p and this is the y of p, and when you replace x of p and y of p in line L2 and in line L1, they satisfy the both equations.